Hello, I'm Haiying. Welcome to Feature Extraction and Feature Engineering. In this video, we'll explore how to deal with challenges with numerical data during feature engineering, focusing on binarization and binning. Addressing these challenges is crucial for building effective machine learning models. We'll first talk about common problems in numerical data. Count variables have the issues of many zeros, over dispersion, and skewed distribution. Continuous variables have scaling issues, outliers, and nonlinear relationships. We'll discuss the solutions to these issues in these and next videos. We often see excess zeros in dataset, such as in a variable indicating the number of years participants stayed in a foreign country. The dataset contains about 1,000 zeros. Using this variable directly for the analysis has the potential to impact the correlation coefficients and regression analysis. This could result in biased estimates, poor model fit, and inaccurate predictions. The strategies to address the zero issue include binarization, binning, log transformation, two-part models, and additive constants. In this video, our emphasis will be on the first two solutions, binarization and binning. As the name suggests, binarization is a technique by which we make the data binary. We can use a binary threshold for making our data binary. The values above that threshold will be converted to 1, and below that threshold will be converted to 0. In this scenario, we will transform the years greater than 0 to 1, so a new binary variable is created. 0 represents not staying in a foreign country, and 1 indicates staying in a foreign country. Binning is a process of grouping numerical data into discrete intervals or bins. It is problematic for models if the number spans several orders of magnitude. Outliers, skewed distribution, or sparse data with few instances in a certain value ranges can impact the performance of statistical models. We'll discuss 3 types of binning: fixed width or equal width binning, equal frequency binning, and customer binning. Fixed width binning or equal width binning has similar concepts. Having fixed or equal width intervals or bins, it divides the entire range of numerical values into bins of equal width or size. Each bin spans a consistent range of values, making all bins have the same width. This is the student's age variable. It is positive skewed distribution with sparse data after age 50. We can generate a new categorical variable with 5 levels, having age ranges such as 21 to 30, 31 to 40, 41 to 50, and so on. Equal frequency binning, also known as quantile binning, is a technique in feature engineering that involves dividing a numerical variable into bins or intervals in a way that each bin contains approximately the same number of data points. The goal is to create bins that have a similar frequency distribution, which is particularly useful for handling skewed datasets. This is the summary writing time variable, a positive skewed distribution with sparse data after 3,000 seconds. We can divide the summary writing time into 10 equal parts, called a decile. Each part represents 10% of the total. We can also divide it into 4 equal parts, called a quarter. Each part represents 25% of the total. Custom binning refers to the process of grouping continuous or numerical data based on specific criteria. The previous age variable can be grouped into three groups: 21 to 30, 31 to 40, and more than 40. I merged the age groups, 40s, 50s, and 60s, into one larger group because of the fewer cases among these three age groups. Final thoughts. Binning is a valuable technique in data preprocessing and feature engineering that serves several purposes, contributing to the effectiveness of data analysis and modeling. Here are some final thoughts on why binning is often used. Simplify the data by converting it into discrete categories or intervals. Binning is useful when the relationship between a predictor variable and the target variable is nonlinear. It allows models to capture patterns in the data more effectively by grouping similar values together within bins. Equal-frequency binning, in particular, can be effective in handling skewed distributions by creating bins with a similar frequency distribution. This helps in situations where certain ranges of values may have a disproportionate impact. Binning contributes to model robustness and computation, especially when dealing with models sensitive to outliers or variations in the data. It can reduce the impact of extreme values by grouping them into specific bins. Thank you. See you in the next videos.